Hello everyone. I welcome you all to this class of thermodynamics, advanced thermodynamics NPTEL lecture. Okay. So in today's class, we are going to study the Lagrangian equation of motion as well as Hamiltonian equation of motion, but that will come in the later part of the class. Initially, we are going to study the optimization and the constraint using Lagrangian multiplier. So what we'll do first, we'll study what is the concept. I'll briefly summarize the concept, and then we're going to solve some couple of examples based on that, and then depending on the time, depending on the time whether we have enough resources, enough time, we'll study the Lagrangian and Hamiltonian equation of motion, and maybe we'll try to find out how these are related and how to find equations of motion using this concept. Okay. So let us wait for a couple of minutes for other people to join in. In the meantime, I'll set up the do the setup of solving the exam. So I hope you can hear me, hear and see me. Okay. So I hope you can see my screen. Oh, I have not written. Okay, just a couple of minutes. So I hope now you can see my screen. Okay. So we'll just wait for a couple of minutes for the people to join in. Okay. So I hope you can hear me and see me, and you can also see my screen. Okay. Before going into before going into the constraint optimization, I would like to go into just a little bit of this introduction to probability. Like given the distribution, how do you calculate the mean, the average of this quantity, then standard deviation, so on and so forth. Okay. So I know that you know most of this thing, but still, just for the sake of completeness, I will tell that that let's say if we have a probability, so there are two kinds of probability distribution. Let me write like this. Probability. There are two kinds of probability distribution. One is the uh, discrete distribution. The other is the continuous distribution. In discrete distribution, as the name suggests, points are not continuous, whereas in continuous distribution, the points are continuous and the it is a smooth function. Right? So now let us try to understand how do you calculate the properties in these yeah. So let's say you have a let's say you have a probability distribution. Let's say the probability distribution is distribution which is given to you is P of Uij. That is probability of atom J occupying the energy state Uj is given by this expression, or it could be, let's say, for example, simplicity we give this is any distribution. Okay, so in that case, the mean or the average. Let me use a different pen for this. Mean or average, also denoted by U bar. So for this discrete distribution, it will be given as summation over all possible state into possibility of that state multiplied by the probability of it occupying that state. Right? Right? This is called as mean distribution or mean. Okay, that is the first result which we are going to use extensively in the later part of the lecture. Then let's say we have spirit of distribution. This is given by quantity. Yes. Mean of the square of the thing, square of the quantity. So this can be given as again summation overall multiplied by probability of occupying that state multiplied by its probability U of J. Okay. This is first expression. This is second expression. Then similarly, we can have mth moment. Mth moment. It can be given u to the power m bar. It is nothing but summation u multiplied by u of m the probability of it occupying that state. Hmm? Next is the how to calculate the standard deviation. Standard deviation also denoted by sigma. Sigma is nothing but square root of variance. It is nothing but square root of u minus u bar whole square. Yeah, whole bar. Right? Okay. Now the next is for the continuous distribution. For continuous distribution, the probability distribution is again, let's say the probability distribution is P of uj. Then in that case, what we have is we have a very good result that P of uj integral into du from minus infinity to plus infinity. This is equals to 1. Right? This is expression number 8. Let's say this is third expression and this is the fourth expression. Right? The next is how to calculate the mean. Mean is equals to u bar. So as this is the continuous distribution, the summation in the discrete distribution gets replaced by integral. Therefore, u bar is nothing but integral minus infinity to plus infinity u into probability of u. So uj multiplied by probability of uj du. Okay. Right? The second one is the square again, which is denoted by u square bar, which is nothing but integral minus infinity to plus infinity u square j multiplied by probability of it occupying j step multiplied by d of uj. Right? This is expression B. Again, the mth momentum we can find is a minus infinity integral to plus infinity u m j multiplied by p of u of j multiplied by d of uj. And standard deviation is given by uj minus u bar j. square of average, which is nothing but equal to integral minus infinity to plus infinity u minus u bar square into p of u. Basically, here it should be j j u g. Okay? So these are some of the very important results which we are going to use extensively in the later part of the class. So does anybody have any questions? Okay. So nobody has any questions. So we'll probably move to the next part of the class. Okay. So here we are going to derive the partition function for the uh, NV ensemble, which is the uh, in which the number of particles in the system, the energy of the system, and the volume of the system remains same. So let us try to derive it. So this is where we are going to encounter first the first time the Lagrangian optimization under constraint. Okay. So now let us consider that we have a container. Okay. Okay. Which has, let's say, the particles like this. These are the atoms like this. Let's say. Okay. So let's we have this container. Let us assume that these are the atoms. Atom, and let's say this is a container. Now let's say what we have. We have m quanta of energy. Like this. M quanta of energy. Now this has to be distributed over n number of particles, right? Let's say this molecule gets one quanta of energy, this molecule gets three quanta of energy, this molecule gets five quanta of energy, so on and so forth, right? So now now what we have to do is we have to find what is the most probable distribution, right? That means what is the probability of this system, right? Okay. So now what we will assume is, first of all, sorry, right? What we'll assume is that epsilon zero amount of energy is given to the n0 type of particle. Epsilon 1 has been provided to n1 particle. Epsilon 2 quanta of energy to n3 n2 particles, such that epsilon m amount of energy is given to the nm particle, okay? such that such that n0 plus is that n0 plus n1 plus n2 plus nm is nothing but total number of particles which were initially present. Similarly, n0, sorry, then n0 into epsilon 0 plus n1 into epsilon 1 plus up to nn epsilon n is nothing but total amount of energy which was E. It's a total. Okay. So let us write this down first of all, and then we'll try to find out the probability distribution. Now let us let us consider a container containing nt, or let's say n number of particles with a volume of V and total energy of Et. Okay. Now let us consider that n0 number of atoms okay the particles have epsilon 0 units of energy, n1 number of particles or atoms have epsilon 1 quanta, or quanta of energy would be the better term here. Quanta of energy, so that nm number of particles, nm number of particles have epsilon n quanta of energy, as shown here, right? As shown here. So as we clearly said initially that n v and t is constant, right? Okay. Let us write in here, saying the total number of particles and total energy of the system is maintained as constant. We can say that n0 plus n1 plus n2 plus up to nm is nothing but n. The total energy is also n0 plus epsilon 0 plus n1 plus epsilon 1 plus up to nm into uh, nm multiplied by epsilon n is nothing but equal to nt, right? So this assumption basically means that it's a closed system, and this assumption means it's an isolated system, right? Then what we can write is, then the total number of ways of achieving this is given by nothing but equal to multiplicity, right? And total number of ways of arranging particles such that nm particles have epsilon have energy equal to epsilon m, uh, such that n0 number of particles have energy equal to epsilon 0, n1 number of particles have energy equal to epsilon 1, and nm so on and so forth, and nm number of particles have energy equal to epsilon m, right? So this multiplicity can be given by total number of states divided by number of ways of arranging n0 particles multiplied by n1 particles multiplied by n2 particles multiplied by nm particles, so on and so forth, right? This is valid when all the molecules or atoms are identical, that is non-distinguishable. Okay? This is okay. This is valid when all the molecules, all the atoms or particles are identical, that is they are non-distinguishable. If they were to be distinguishable, then this formula would change, right? Therefore, the most probable distribution is given by maximizing this multiplicity, right? Following maximization problem. Maximize W, right? Such that n0 plus n1 plus up to nm is equal to n, and n0 epsilon 0 plus n1 epsilon 1 plus up to nm epsilon 1 is equal to et, which implies maximize n factorial divided by n0 factorial, n1 factorial up to nm factorial, such that n0 plus n1 plus up to nm is equal to n, and n0 epsilon 0 plus n1 epsilon 1 plus up to nm epsilon n is equal to et. Right? Now, to solve this, we need Lagrangian multiplier. To solve this maximization problem, we need Lagrange multiplier method. Right? Now, maximizing W is nothing but equal to maximizing ln of W, because as W increases, so do the ln. And now why we are using ln is because if you remember in the previous classes we have studied something called as Stirling's approximation. When n is very high, then we can write that ln of n factorial is nothing but equal to n ln n minus n, right? When order of magnitude of n is very far high, right? Hence, what we can write is expressing above problem, which is nothing but maximization of W under some constraints okay, expressing above problem in general maximization problem as the constraint have summation as the constant m, n0, n1, and then energy quantize epsilon 0, epsilon 1 up to epsilon n. Therefore, maximize W is equal to nothing but maximization of summation j is equal to 0 to m and j factorial divided by product of j is equal to 0 to m and j factorial. Remember here the factorial is outside, whereas here the factorial is inside. With constraint, constraints are we are writing g1, which is equal to summation j is equal to 0 to m and j minus n is equal to 0 and g2 is equal to summation j is equal to 0 to n and j epsilon j minus et is equal to 0. Right? The Lagrangian multiplier, we should have this g1 and g2 always 0. And those who make it 0, those are called as Lagrangian multiplier. Yeah, right? So this is the problem statement. So now let us try to solve it. Maximization of W is equivalent to maximization of ln W. Hence, we can change the problem as maximize ln of W, meaning maximize for all ng ln of summation j is equal to 0 to m and j factorial divided by product of all j is 0 equal to m and j factorial with the constraint g1 is equal to summation j is equal to 0 to m and j minus n is equal to 0 and g2 which is equal to summation j is equal to 0 to m and j epsilon j minus et is equal to 0. Right? Simplifying, we get maximization of all nj such that ln of summation j is equal to 0 to m nj factorial minus ln of product of j is equal to 0 to m nj factorial. Why? Because ln of a by b is nothing but ln of a minus ln of b with the constraint g1 is equals to summation j is equals to 0 to m nj minus n is equals to 0 and g2 is equals to summation j is equals to 0 to m nj epsilon j minus et is equals to 0. Okay, so it's going to involve a lot of math, right? So just keep on follow as I am doing it, and if you have any question you can just stop me there itself and ask me. Okay, don't wait for everything to end, because if only even if you don't even if you don't understand just one step, there is a possibility that you may not be able to understand the full derivation, right? So please ask me question whenever you feel, whatever you are whatever is not clear to me at that point itself. Okay. So does anybody have any question till now what we have covered? Okay. So now let us try to do it. So now this is a summation, right? This is a product. Okay. So this is ln summation, ln of a summation, and this is ln of a product, right? So then we can write nothing but maximization over all nj for, right? Here we are applying the Starlink's approximation, right? So what we get, summation j is equals to 0 to n and j into ln of summation j is equals to 0 to n and j minus summation j is equals to 0 to m and j minus ln of product of j is equals to 0 to m and j factorial. So here what we have done is, here we have applied Stirling's approximation, which tells us that ln of n factorial is nothing but n ln n minus n when n is very large, right? Now the constraints are g1 is equals to summation j is equals to 0 to m and j minus n is equals to 0, then g2 is equals to summation j is equals to 0 to m and j epsilon j minus et is equals to 0. So let me just use a different color to show different steps, right? Now again we use simplification, right? So now here what we have, here we have a product ln inside a product, right? That means ln of a into b ln of whole a. This is of the form ln of a into b into c up to like this. This is nothing but equal to ln of a plus ln of b plus c. And hence we can write this as summation of ln of nj factorial, right? And hence that is what we are going to do here, that maximize over all nj such that, yeah, summation j is equals to 0 to m nj, this term will come as it is multiplied by ln of summation j is equals to 0 to m nj minus summation of j is equals to 0 to m nj minus summation j is equals to 0 to m ln of nj factorial. Now from where did it come? It come from here. Normal logarithm. Right? Is that the constraint, sir? What are the constraints? Constraints are g1 is equal to summation j is equal to 0 to nj minus n is equal to 0 and g2 is equal to summation of j is equal to 0 to nj epsilon j minus n is equal to 0. Again simplifying, what we get is the following: maximize over all nj such that summation j is equal to 0 to m nj multiplied by ln of summation j is equal to 0 to m nj minus summation of j is equal to 0 to m nj minus, okay, again here we are using Stirling's approximation, okay, minus of summation j is equal to 0 to m nj into ln of nj minus nj. And what are the constraints? Just that summation j is equal to 0 to m nj minus n is equal to 0 and summation j is equal to 0 to m nj epsilon j minus et is equal to 0. Again we are going to simplify and open up the brackets. So what we get is maximize over all nj such that summation j is equal to 0 to m nj multiplied by ln of summation j is equal to 0 to m nj minus summation j is equal to 0 to m nj minus opening now the brackets minus summation j is equal to 0 to m nj ln nj plus summation j is equal to 0 to m nj. Now these two terms they get cancelled and we are left with maximize nj, right? Summation of j is equal to 0 to m nj into ln of summation j is equal to 0 to m nj minus summation j is equal to 0 to m nj ln nj, right? And what are the constraints? These are the constraints. Summation j is equal to 0 to m nj minus n is equal to 0 and minus it is equal to 0, right? Now the maximization problem then now becomes, right? Right? Maximize, I think it's better to go to next page. maximization. Okay, now maximization problem becomes maximize over all nj such that summation j is equals to 0 to m and j into ln of summation j is equals to 0 to m and j minus summation j is equals to 0 to m and j ln ng, right? Such that g1 is equals to summation j is equals to 0 to m and j minus n is equals to 0 and g2 is equals to summation j is equals to 0 to m and j epsilon j minus it is equals to 0. And this is the maximization problem. This is the final maximization problem, right? Now the same problem in Lagrangian multipliers method can be written as the same problem as mentioned above can be written in terms of Lagrange multiplier as follows: dou by dou nj of ln omega minus lambda 1 minus lambda 1 minus lambda 1 into dou by dou nj of g1 minus lambda 2 dou by dou nj of g2 is equals to 0 for all nj, right? Now let us highlight this one and try to solve this one. Okay? Now let us try to find the first step, which is dou by dou. Different color, so blue. Now dou by dou nj of ln omega is what? Dou by dou nj of summation j is equals to 0 to m nj into ln of summation j is equals to 0 to m nj minus summation j is equals to 0 to m nj into ln nj, right? Now here what we'll do is we'll apply the product rule, right? Just a minute. I hope this is clear to everyone. If you have any doubt, you can just straight away ask me. Okay. Anybody has any doubt? No? Okay then. We will move forward. Okay. So this is nothing but equal to dou by dou nj. So first of all, the way to solve is, let us do substitution. Let us say that summation j is equal to 0 to m nj is equal to x. This implies, this is a different color for this. Let's say that summation j is equal to 0 to m nj is nothing but x. Then what does this mean? This means that dou by dou nj of summation j is equal to 0 to m nj is going to be del x by del nj. Right? Therefore, what we can write is dou by dou nj ln w is equal to dou by dou nj of x into ln x minus summation j is equal to 0 to m nj into ln nj. Right? This means this is equal to x into dou of ln x by dou nj plus dou x by dou x into ln x minus dou by dou to the like this, dou by dou nj of summation j is equal to 0 to nj into ln nj. Therefore, dou by dou nj of ln of w is going to be equal to x into dou ln x by dou x plus ln x into dou x by dou nj minus summation j is equal to 0 to m of nj into dou ln nj by dou nj plus ln of nj into dou nj by dou nj. Yeah, is this clear to everyone, or anybody has any doubt? Yeah? What does this mean? Right? This means that dou by dou nj of ln omega is going to be nothing but x into dou ln x by dou nj plus ln of x into dou x by dou nj minus dou by dou nj of n0 ln n0 plus nj nj ln nj plus nm ln nm. Right? This means what? This means dou by dou nj of ln of omega is going to be x into dou ln x by dou x multiplied by dou x by dou nj plus ln of x into dou x by dou nj minus dou by dou nj of n0 ln n0 minus dou by dou nj of nj ln nj minus dou by dou nj of nm ln nm. partial derivative with respect to nj is impressed dou by dou nj, right? This implies dou by dou nj actually means dou by dou nj some quantity at all apart from nj are constant. Therefore, dou by dou nj of ln of omega is nothing but x by x into 2x by dou nj plus dou x by dou nj into ln of x minus dou by dou nj of nj then nj. Why? Because all other things become constant, right? So their derivative becomes 0. Dou by dou x of dou nj into 1 plus ln of x minus nj by nj into dou nj by dou nj plus ln of nj into dou nj by dou nj. This implies dou by dou nj of ln of omega is going to be equal to dou by dou nj of this is substituting x, j is equals to 0 to 1 nj into 1 plus ln of x minus of 1 plus ln of nj. This is nothing but dou by dou nj of n0 plus n1 plus up to nj, which is up to n multiplied by 1 plus ln of summation j is equals to 0 to 1 nj minus 1 minus ln of nj plus to dou nj by dou nj into 1 plus ln of summation j is equals to 0 to 0 to m nj minus 1 minus ln of nj. Dou by dou nj ln of omega is equals to 1 plus ln of summation j is equals to 0 to nj minus 1 minus ln of nj, right? This means dou by dou nj of ln of w is equals to ln of summation j is equals to 0 to nj minus ln of nj, which is nothing but ln of summation j is equals to 0 to 1 nj divided by nj. Okay? Therefore, what we can write is dou by dou nj of ln omega is equals to ln of summation j is equals to 0 to 1 nj divided by nj. This is b. Now let us move back to this expression. So this we have just evaluated. Now we'll evaluate this one. Let us use a black color for this. Okay. dou G1 by dou Nj, or dou by dou Nj of G1 is nothing but dou by dou Nj of summation J is equal to 0 to N Nj minus N is nothing but dou by dou Nj of summation J is equal to 0 to N Nj minus dou by dou Nj of N. Simplifying, writing the terms, we get N0 plus N1 plus N2 plus up to Nj plus up to Nm minus dou Nj by dou Nj is nothing but dou by dou Nj of N0 plus dou by dou Nj of N1 plus dou by dou Nj of Nj plus dou by dou Nj of Nm minus dou Nj by dou Nj is equal to 0 plus 0 plus 1 plus 0 minus dou Nj by dou Nj is equal to 1 minus, yeah, this is not actually Nj, this is total N. Also not Nj, this is total N. This is what? 1 minus 0, which is 1. Therefore, what we can say is dou by dou Nj of G1 is equal to 1. This is option C. Now then look at dou by dou Nj of G2 is equal to what? This is equal to dou by dou Nj of summation J is equal to 0 to 1 Nj epsilon J minus N, which is equal to dou by dou Nj of summation J is equal to 0 to 1 Nj epsilon J minus dou N by dou Nj, right? Which is equal to dou by dou Nj of summation J is equal to 0 to 1 Nj epsilon J minus 0, right? Therefore, dou by dou Nj of G2 nothing but dou by dou Nj of N0 epsilon 0 N1 epsilon 1 Nj epsilon J Nm epsilon 1 dou by dou Nj of G2 is nothing but dou by dou Nj of N0 epsilon 0 plus dou by dou Nj of N1 epsilon 1 dou by dou Nj of Nj epsilon J dou by dou Nj of Nm epsilon 1 dou by dou Nj of G2 is equal to 0 plus 0 plus 1 plus 0. Therefore, dou by dou Nj of G2 is equal to 1. Sorry, this is not equal to 1. This is equal to epsilon J. Right? is option B. Now from A, B, C, and D, we get the final expression for that would be the minus of ln of nj by summation. Sorry, the final expression would be dou by dou nj of ln of w is equals to minus ln of nj by summation nj. This implies minus minus ln of nj by summation nj minus lambda 1 multiplied by 1 minus lambda 2 epsilon is equals to 0, which implies ln of nj by summation nj is equals to minus lambda 1 minus lambda 2 epsilon 1. This implies nj by summation j is equals to 0 to 1 nj is equals to exponential of minus lambda 1 minus lambda 2 epsilon j. Now the above equation is the most probable distribution. Yeah. Nobody has any doubt? They can ask. If anybody has any doubt, they can ask. Now the question is, how to find lambda 1 and lambda 2. For that we use a simple trick. We know that summation j is equals to 0 to m and j is nothing but n. Therefore, taking summation on both sides of equation E, we get summation j is equals to 0 to m and j by summation j is equals to 0 to m and j is equals to summation j is equals to 0 to m exponential of minus lambda 1 minus lambda 2 epsilon j. Now remember that this is already summation. So summation under summation is nothing but summation only. This is already summation. Hence is a constant and can be taken out from the outer summation, right? This implies summation of j0 to m and j divided by summation j0 to m and j is equals to summation j is equals to 0 to l exponential of minus lambda 1 minus lambda 2 epsilon j. This implies 1 is equals to summation j is equals to 0 to l exponential of minus lambda 1 minus lambda 2 epsilon j. This implies 1 is equals to summation j is equals to 0 to l e to the power minus lambda 1 into e to the power minus lambda 2 epsilon j. Now note that this is constant and hence can be taken out of the outer summation. Therefore, 1 is equals to e to the power minus lambda 1 multiplied by summation of j is equals to 0 to l e to the power minus lambda 2 epsilon j. This implies 1 by e to the power minus lambda 1 is equals to summation j is equals to 0 to l e to the power minus lambda 2 epsilon j, which implies e to the power lambda 1 is equals to e to the power minus lambda 1 is equals to 1 by summation j is equals to 0 to l e to the power minus lambda 2 epsilon j. Now let's call this as expression 5. Now then, put the equation f in equation e, we get nj by summation j is equals to 0 to l nj is equals to e to minus lambda 2 by epsilon j divided by summation j is equals to 0 to l e to the power minus lambda 2 epsilon j, right? And this is what is called as Boltzmann relation, Boltzmann distribution. This is like a Boltzmann distribution. Right? And let us assume that lambda 2 is equals to 1 by kpt, which is nothing but beta. Therefore, we get nj by summation nj is equals to e to the power minus epsilon j by kbt divided by summation e to the power minus epsilon j by kbt. Or in other words, we can write this as exponential of minus epsilon j by kbt divided by exponential of minus epsilon j by kbt. Right? This is what is the partition function for canonical ensemble, microcanonical ensemble. This is the most probable distribution or in, right? So microcanonical ensemble partition function is what? Partition function is denoted as q and is equals to summation exponential of minus epsilon j by kbt, j is equals to 0 to n, which is nothing but j is equals to 0 to n exponential minus beta into epsilon j, right? Does anybody have any doubt in this? Okay, if there are no doubts, then we'll solve an example. Okay, that is question number 1. Use the method of undetermined multipliers to show that minus summation j is equals to 1 to n pj into n pj subject to the condition summation j is equals to 1 to n pj is equals to 1 is a maximum when pj is equals to constant. I'll give you a couple of minutes for to solve this question, and then if nobody and then I'll solve it. Sorry. Mhm. Yeah. So it's 8:13. I'll give you 5 minutes to solve it. I hope the question is clear to everyone. If anybody has doubt understanding the question, they can ask me. And for those who the question is clear, they can try to solve it. So this question is very similar to what we did just now. That is a method of Lagrangian multiplier. You just have to use that method, and you will find that many of the derivatives which come in that fashion, we have just solved it just now, right? So I think you will be able to do it. I'll give you a couple of minutes for you to solve it. So anybody able to solve the question? Anybody has any answer? So hint would be to solve it via method of Lagrange multiplier. So what we'll do, we'll take a short break of 5 minutes. For those who want to drink water or want to go to washroom, they can go. And then for those, in the meantime, those who want to try the problem can try as well. Anybody able to solve it? Yeah. So I hope everybody has written. Anybody able to solve the problem? The hint would be to use a Lagrangian multiplier method. And anybody able to solve it? Okay. So let me just go ahead and try to do it. So the maximization problem is what is, let us first see. So what has been asked is use the method of an undetermined multipliers to show that summation j equal to 1 to n pj into ln pj negative is subject to the condition that summation j is equals to 1 to n pj is equals to 1. is a maximum when Pj is equal to constant. Okay. The maximization is maximize minus summation j is equal to 1 to n Pj into ln of Pj subject to the condition that summation j is equal to 1 to n Pj is equal to 1. Now let f is equal to that maximization part. Summation j is equal to 1 to n Pj into ln of Pj and g is equal to summation j is equal to 1 to n Pj minus 1 is equal to 0. Then the Lagrangian formulation of above maximization problem is given as dou f by dou Pj minus dou f by dou Pj. Dou f by dou Pj minus lambda dou g by dou Pj is equal to 0. Let's call this as question number 1. Now take this part. Dou f by dou Pj is nothing but dou by dou Pj of minus of summation j is equal to 1 to n Pj into ln of Pj, right? This is going to be nothing but dou by dou Pj of, this is the minus, we can take the minus now, which is nothing but summation j is equal to 1 to n Pj ln of Pj. This minus dou by dou Pj of P1 ln P1, right? Plus P2 ln P2 plus up to Pj ln Pj plus up to Pm ln Pm. This is nothing but 0 plus 0 plus, because all other except 1 is constant, it will be 0. Oh, sorry. Plus with dou by dou Pj, everything is in minus of Pj into ln of Pj that is 0. It is minus dou by dou Pj of Pj ln Pj. This is nothing but minus dou by dou, sorry, which is equals to minus of Pj into dou ln Pj by dou Pj plus ln of Pj into dou Pj by dou Pj. This implies dou f by dou Pj is equals to minus of Pj into 1 by pj plus ln of pj, which is nothing but minus of 1 plus ln of pj. This implies dou f by dou pj is minus of minus ln of pj. Let's call this as expression 2. Now go to the constraint part. Let me use a different color. Now constraint part is now constraint part is dou g by dou pj, which is nothing but dou by dou pj of minus summation j is equals to 1 to n pj, which is nothing but dou by dou pj of p1 minus, we can take minus out, p1 plus p2 plus up to pj plus up to pn or pn. This implies dou g by dou pj is equals to minus 1. Let's call this as expression 4. Now from 1, 2 and 3 we get dou w by dou pj is equals to minus 1 minus of ln of pj minus lambda into 1 is equals to 0. Hence we can say pj star, which is the most probable distribution, pj star is going to be exponential of minus 1 minus lambda, problem 4. Okay, now how do we calculate lambda? For this we use a simple stick. Now we know that summation pj star j is equals to 1 to n is equals to 1. This implies summation j is equals to 1 to n e to the power minus and minus lambda is equals to 1. Let us call this as expression point. Now apply normalization to equation 4 using equation 5. We get pj star is equals to e to the power minus 1 minus lambda divided by summation j is equals to 1 to n e to the power minus 1 minus lambda. Hence true. Right? Anybody has any question? I'll wait for 2 minutes if anybody has any questions. Otherwise, we'll move on to the next question. Anybody has any doubt? If you have any doubt, you can ask me. I'll wait for a couple of minutes. Else I'll give to the else I will give the new question. Let me write down so that those who don't have any doubt, they can proceed with the next question. And for those who have any doubt, they can ask me. Okay. This will be, I think, third question of the day. This is based on Newtonian and Lagrangian equation of motion. Okay. So for a particle moving in 3 dimension under the influence of a physically symmetrical potential of the form U is equals to U of R. Write down the Lagrangian equations of motion in the spherical coordinate, which are R, theta, and phi, so that Hamiltonian is equals to Lagrangian kinetic energy plus potential energy from Hamiltonian is equals to PIQi minus L. So for those who don't have any doubt in the previous question, can go ahead with this question. And for those who have doubts, they can still ask me. I'll wait for a couple of minutes for you guys to attempt the question. Anybody has any doubts? Okay, so we'll move on with the next question. Was anybody able to solve this new question? So let us first read the question. So for a particle moving in 3 dimensions under the influence of a spherically symmetrical potential, which is of the form U is equals to URR. Okay, so this has been given. And now what are we asked? We are asked to write down the Lagrangian and Hamiltonian equations of motion in the spherical coordinate. And then we have to show that Hamiltonian is nothing but equal to kinetic energy per potential energy from starting with Hamiltonian is equal to summation of PIQi minus N. Right, so there are two parts. So first, let us move on to the first part. Okay, so let us start. Solution. Let x, y, z be the Cartesian coordinates of point. Then the relationship between then the relationship between Cartesian and spherical coordinates is given as x equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. Now here we know that Lagrangian is nothing but kinetic energy minus potential energy, where kinetic energy is nothing but all the vibrational degrees of motion v square plus y square plus dz square, and potential energy is equal to u of r. Now Vx is equal to dx by dt, which is over d by dt of r sin theta cos phi. Therefore, therefore Vx is equal to x dot, which is equal to r dot sin theta cos phi plus r into theta dash into cos theta cos phi minus r sin dot phi dot sin theta sin theta sin theta sin theta sin phi. Right? Similarly, Vy is equal to y dot is equal to r dot sin theta sin phi plus r theta dot cos theta sin phi minus r into phi dot into sin theta cos phi. Right? For z, we can write similarly z is equal to vz is equal to z bar is equal to r dot cos theta minus r theta dot sin theta. Now therefore Vx square is equal to x square r dot sin theta cos phi plus r theta dot cos theta cos phi minus r into psi dot sin theta sin phi square. Right? Similarly, Vy square is equal to y dot square is equal to r dot sin theta cos phi plus r theta dot cos theta cos phi sorry, yeah, minus correct again Vy square, which is equal to y dot square is equal to r dot sin theta cos phi plus r r theta dot cos theta cos phi minus r phi dot sin theta sin phi square. Vz square, Vz square is equal to z dot square, which is equal to r dot cos theta minus r theta dot sin theta whole square. Therefore, kinetic energy is equal to 1 by 2 Vx square, Vy square, Vz square, which is nothing but m by 2 into r dot sin theta cos phi plus r theta dot cos theta cos phi minus r phi dot sin theta sin phi square plus r dot sin theta cos phi plus r theta dot cos theta cos phi minus r into phi dot sin theta sin phi whole square plus r dot cos theta minus r theta dot sin theta whole square upon simplification we get kinetic energy is equal to m by 2 Vx square, Vy square, Vz square, right? This is what equal to m by 2 into r dot square plus r square, the dot square plus r square sin square theta phi dot square plus u of r. Now equation of motion for Lagrangian is d by dt of dou L by dou Ri minus dou L by dou Ri is equal to 0, where Ri dot is nothing but r dot theta dot and phi dot. Now d by dt into dou L by dou Ri or dou L by dou r dot minus dou L by dou R is equal to 0. Let us call this as expression number 1. Now, substituting value and R dot is equal to R in equation 1. We get d by dt of dou by dou R dot of m by 2 R dot square R theta dot square square plus R square A square theta and phi dot square plus u of R minus dou by dou R of m by 2 R dot square plus R square theta dot square plus R square sin square theta I dot square plus u of R upon simplification. We end up with following expression, which is R double dot minus mr theta dot square plus sin square theta phi dot square plus 2 by 2 r of u of r. Substituting values and ri dot is nothing but theta dot equation 1. We get d by dt of dou L by dou theta dot minus dou L by dou theta equals to 0. This implies d by dt of dou by dou theta of m by 2 r dot square plus r square theta dot square plus r square sin square theta phi dot square plus u of r minus dou by dou theta of m by 2 r dot square plus r square theta dot square plus r square sin square theta phi dot square plus u of r equals to 0. Upon further simplification, we get m m into theta double dot into r square plus 2 m r dot theta dot minus m r square phi dot square sin theta is equals to 0. Now, substituting values and ri double dot in equation 1, we get d by dt of dou L by dou phi dot minus dou L by dou phi is equal to 0, right? Which means d by dt of dou phi dot, sorry, d by dt of dou by dou phi dot of m by 2 into r dot square plus r square theta dot square plus r square sin square theta phi square plus u of r minus dou by dou phi m by 2 r dot square plus r square theta dot square plus r square sin square theta phi square plus u of r is equal to 0. Upon further simplification, we get m into r square into phi double dot sin square theta plus 2 m r dot phi dot sin square theta plus 2 m r square theta dot phi dot sin theta cos theta. Hence, the Lagrangian equation of motion for given problem statement is as follows, which is m r double dot minus m r theta dot square plus sin square theta into theta dot square plus dou by dou of dou by dou r u of r is equal to 0, m into theta dot into r square plus 2 m r into r dot into theta dot minus m r square I dot square sin theta is equal to 0, and the third one is m into y square, sorry, m into r square y double dot sin square theta plus 2 m into r dot into phi dot into sin square theta plus 2 m r square theta dot phi dot sin theta cos theta. So these three are the final equation of motion for the problem statement given with the constraint already provided, right? So with this, we have covered all the essential and all the essential topics which have been covered till now and which are going to play an important role in the upcoming future. To summarize, in present class, first we have seen and we have seen and understood what is Lagrangian method of multiplication, why it is required, and why it is one of the best one known, which can while it is known as best one, which can use the Lagrangian method of multiplier to find the partition function or the most probable distribution of multiple cases which are very relevant for our molecular simulation, right? Further, we also saw, but prior to that, we saw some very important aspects of probability. We saw that there are two types of probability distributions. One is a discrete one, and another is a complete one. Another is a continuous one. Then further, we also found out how to find different first momentum, second momentum, and so on and so forth, such that mth momentum or momentum, the probability distribution function for both discrete as well as continuous distribution. Then after that, we studied about Lagrangian method of multiplier, and then we solved a question for to understand, to have a really deep understanding, but also practical utility of Lagrangian method of multiplier. Then at the end, we solved one question which is based on the equation of motion using a Lagrangian as well as Hamiltonian way of doing things, right? Lagrangian and Hamiltonian ways. We found the equation of motion for a particle moving in 3 dimensions under the influence of a spherically symmetric potential. So I hope this is clear to everybody, and people and you have enjoyed this class. If you have any doubt, please let me know. Right? Does anybody have any doubt? I'll wait for a couple of minutes for people. For those who have any question, for those who do not have any question, they can leave. So I thank you all. So I don't see any question. So I thank you all for attending this class, and I hope to see you again in the next class and all the classes henceforth. And I hope these classes which we have taken are going to help you in solving the assignment problems, which currently is the aim for all these things. If okay, so I don't see any questions. Maybe I'll wait for a couple of minutes before ending the session. So I don't see any questions. I hope you can hear me and see my screen. Okay, so I see no questions. But I'll wait for a couple of minutes. Nobody has any questions. Then I think we can end the session. So I thank you all once again for attending this class, and I hope to see you all again in the next class. Thank you.